All right, guys, in lesson 7-8, we're trying to represent growing patterns with finding an equation. So I can represent this growing patterns, and in this case, we're looking at the number of triangles I have, and then how many toothpicks it would make, or it would take to make that. All right, so I kind of drew a little picture here to get started. To draw one triangle, I need 3 toothpicks. Okay, and 2, it says 5 toothpicks. So the second one's kind of upside down, right? So you got your first triangle, and then you make the other one with 2 more toothpicks, because it looks like every time I add one toothpick, or excuse me, one triangle, I'm adding 2 toothpicks. And I see that pattern again. I add another triangle, I add another 2 toothpicks. Again, so if I get 3, I've got 1, 2, 3, 4, 5, 6, 7. I can actually count those and see those, and this pattern keeps going on forever. Okay, and every time I add one triangle, I get 2 more toothpicks to make it, because they share a side here, don't they? Okay, so I don't have to add another one. I don't add 3 every time, because naturally you're thinking triangles. If you look here, I've got one triangle, it's 3 toothpicks, because there's 3 sides on a triangle. So it looks like I triple, but we find out I don't triple that because they share a side. If I triple 2, it'd go to 6. So I'm just not tripling. It's not some simple pattern. Growing patterns can be more complex. But if I know the one before it, then I know I can just, every time I add a triangle, I add 2 toothpicks. All right, I can easily see that pattern. But what if I wanted to find, the 100th triangle? I can only use that if I knew the 99th. If I knew how many toothpicks it took to make the 99th, I'd have to add 2 from there. But I don't have that. I don't know how many are 99. I don't want to draw them to get that. So we need to come up with some sort of an equation and see what's happening. All right, so this is where it becomes a little abstract. The pictures can help you. I see we're adding 2. But what are we doing? There's going to be more than one step. It's not just tripling. How do I represent this adding 2? Because to keep the same rate, we know we can't just do things with adding, in this case, unless I know the one before. So you got to kind of find a pattern here, and these can be really, really tough. Some kids are better at seeing this than others. There's formulas that could work, that might be a little more complex than others. They could all break down to the similar if you combine like terms and things, so you could get it down to the same formula. But what I'm seeing here, and again, these are hard for me too. I always struggle with these. But what am I doing in the X to get the number of toothpicks, the Y? So X is going to represent the number of triangles. So if I double, like I see, for example, when I have one triangle, what if I just started with 1 toothpick? Okay, and I have to add 2 more. Could I double it? So if I take my triangles, okay, and I double them, so take it times 2. So if I took this 1, which would be my X, and I took 2 times 1 then, so I double whatever the triangle is, and then add 1 more. Does that get me to 3? So I take this number of triangles, 1 triangle. If I take that triangle and double it, I plug that 1 in here. 2 times 1 is 2. That gives me 2 toothpicks, right? Plus 1 more gets me to 3. So the pattern I'm trying to look at now, I know I just didn't say it tripled because that didn't work. That's what I looked at first. Can I get it just by tripling? Didn't work. But what if I double and add 1? That gets it to 3. So let's see if that would work for the next one. What if I plug in a 2? If I double the 2, 2 times 2 is 4, plus 1 gets me 5. So I'm seeing a pattern that if I double the number of triangles, or double my X, and add 1, I'm always going to get to the number of toothpicks. Again, can I double 3? That's 6. And then add 1, it gets me to 7. So I'm seeing this repeating pattern, and I almost look and I think like this 1 could represent that 1 toothpick stick. Okay, well, that 1 toothpick, and if I double that, that gives me 2, and then add 1 more. Again, we're adding that 1 more. We're sharing a side is what causes this to happen, and why we're not just tripling, because we're sharing that side. So my pattern has to represent that I'm not adding 3 on every time. Again, there may be other formulas that you guys came up with that could be equivalent to this, and different things you could do. But when it comes down to it, we're always doubling and adding 1. Doubling and adding 1. Okay, so the equation, I would say then 2 times x, because x represents the triangles, and add 1. An equation means we have to have an equal sign. That will always equal y, which we know y represents the number of toothpicks. So if I double the triangles and add 1, I will come up with the number of toothpicks. And it talks about here to substitute one of your x values into your equation, which I've already done. But let's do that again here with 3. So if I've got 2 times the quantity x plus 1 equals y, let's plug in x is 3 like we said up here. We can do that with parentheses. And then follow your order of operations. 2 times 3 is 6, plus 1 is 7. And we know that's correct because it worked. I plugged it up in here and did the same thing and showed. You usually want to test it, with 2 or 3 of them to make sure it's correct. Because sometimes it might work for one and not the other. So make sure you do that and substitute it in. And we found our pattern for this growing number of toothpicks to make this triangle pattern.